So today we're going to be talking about arithmetic sequences and series. So, in an arithmetic sequence and series, we have this equation right here. In this equation, we have A1, which stands for the first term, we have D, which stands for the common difference, and we have N, which stands for the number of terms. So now let's look at the first problem that we have right here. So our first term in our arithmetic sequence is 4. So that's what we put in for our A1. Now from here we can see that this has a pattern that is going up by 7. So that's what our D is. We know our A1 is going to be equal to 4. D is equal to 7. It's now asking us to find the 28th term of each sequence. But before we do that, let's find the equation. So we're going to put in our values for A of n is equal to 4 plus 7 times n minus 1. Now what we're going to want to do is we're going to write this in simplest form. So what we're going to do is we're going to distribute our 7. We're going to get A sub n is equal to 4 plus 7n minus 7. Which then we get as our final equation, A sub n is equal to 7n minus 3. There's our equation. Now we can use this to find our 28th term. So to find our 28th term, we do A sub 28 is equal to 7 times 28 minus 3. When you put this in your calculator, you get A sub 28 is equal to 193. And that is our final answer. Now let's move on to the next one. So our A1 is our first term here, 26. Now we can see from here that our pattern is going consistently down by 8. So our D is going to be equal to negative 8. Now let's find our equation. So A sub n is equal to 26 minus 8 times n minus 1. Just as before, we're going to want to simplify this, so we're going to distribute our 8 to get A sub n is equal to 26 minus 8n plus 8. When we combine like terms, we get A sub n is equal to 34 minus 8n as our final equation. We can now use this to figure out what our 28th term is going to be. So, A sub 28 is equal to 34 minus 8 times 28. When you put this in the calculator, you should get A sub 28 is equal to negative 190. Now let's move on to the next problem. So, find n if A1 is equal to 2, AN is equal to 74, and D is equal to 3. So, we know we have our original formula, A sub n is equal to A1 plus D times n minus 1. It's telling us here that our A sub n is equal to 74, our A1 is equal to 2, our D is equal to 3, and we are looking for n. We subtract 2 from both sides, and we get 72 is equal to 3 times n minus 1. Divide both sides by 3. We get 72 divided by 3 is 24 is equal to n minus 1. We add 1 to both sides, and we get 25 is equal to n as our answer. Now, just a side note on this problem. N cannot be a decimal, and it cannot be negative. And this makes sense if you think about it, because since we're looking at a certain number of terms, you can't have a negative number of terms. You can't have a decimal number of terms. So it makes sense that n cannot be a decimal and it cannot be negative. Now let's move on to the next problem. So, find the first term in the common difference of an arithmetic sequence if the fifth term is 24 and the 12th term is 3. So, just as before, we know that we have a sub n is equal to a1 plus d times n minus 1. We're going to substitute in both of our values that were given here into two different equations, and then we're going to solve. So what I mean by that is we're going to put 24 in for our a of n, and we're going to put 5 in for our n value. Since this is the fifth term in the sequence, and the fifth term is 24, n is going to be equal to 5, and a sub n is going to be equal to 24. Now, same thing with this part of the problem. We're going to have 3 is equal to a1 plus d times 12 minus 1. Let's simplify both these equations a little bit. We're going to get 24 is equal to a1 plus 4d, and this one is 3 is equal to a1 plus 11d. Now we're going to use systems of equations to solve for a1 and d. So I'm going to solve on this side for a1. I'm going to subtract 4d from both sides and get a1 is equal to negative 4d plus 24. What I'm going to do now is I'm now going to substitute my value for a1 on this side in for a1 over here to get 3 is equal to negative 4d plus 24 plus 11d. When I combine my like terms, I get 7d plus 24, subtract 24 from both sides, to get negative 21 is equal to 7d, divide both sides by 7, and d is going to be equal to negative 3. Now to get my value for a1, I can substitute d is equal to negative 3 into either equation. I'm going to substitute it into the equation on the left. a1 is equal to negative 4 times negative 3 plus 24. a1 is equal to 12 plus 24, and a1 is going to be equal to 36. And these are our two answers. This question doesn't ask you to do this, however, I'm going to do it anyway. I'm going to substitute both these values in to figure out what the equation would be for these given statements. So, a sub n would be equal to 36 minus 3 times n minus 1. And then simplified, a sub n is equal to 36 minus 3n plus 3, and a sub n would be equal to 39 minus 3n. Now, this isn't an answer for this type of question because it doesn't ask us. However, if it did ask us to write the final equation, that's what it would have been. Now let's move on to the next one. Patrick wants to build a tower of blocks with 50 blocks on the bottom, and each row reduces the blocks by 2. How many blocks are in the 23rd row? So, in this word problem, it tells us a1 is equal to 50. Each row reduces by 2, so d is equal to negative 2. And we are looking for the 23rd row, so n is equal to 23. We know our equation, a sub n is equal to a1 plus d times n minus 1. We're simply going to substitute these values in for our equation and solve. A sub n is equal to 50 minus 2, 23 minus 1. A sub n is equal to 50 minus 2 times 22. I'm going to change this to actually a sub 23 because that's the value that we're finding. So then we have a sub 23 is equal to 50 minus 44. And our final answer is a sub 23 is equal to 6. So our answer is 6 blocks. Now let's move on. Now, this is what we're going to be talking about next is the arithmetic series. So, this is when, if we were looking at the same problem that we have here, if we change the problem to, instead of asking how many blocks are in the 23rd row, how many blocks are there total? So that's what we're going to be talking about here. We're going to be adding up all of our values here. So, these are the two formulas that we have that add these values, and they are essentially the exact same thing. So we know a sub n is equal to a1 plus d times n minus 1. And this is that formula with that, exactly that, just substituted in. Let me show you. A sub n is equal to n over 2 times a1 plus an we know is equal to a1 plus d times n minus 1. We simply combine our like terms here to then get n over 2 times 2a1 plus d n minus 1, which you can see is the exact equation we have up here. So let's look at the first problem. Find the sum of the first 16 terms of the following series. We can see that our a1 is equal to 5. This is consistently going up by 2, so our d is going to be equal to 2, and our n is going to be equal to 16. That's the number of terms we're looking for. So now we can substitute these values into our equation. I'm going to use the second equation. So s of 16 is equal to 16 over 2 times 2 times 5 plus 2, 16 minus 1. Do the rest of the math and figure all this out. 8 times 10 plus, this is going to be 15 times 2 is 30. S sub 16 is equal to 8 times 40, which is going to be equal to S sub 16 is equal to 320. That's our final answer. Now let's move on to the next one. Find the sum of the first 22 terms of the following series. We can see here that 82 is our A1. And we can see that the pattern is that it's consistently going down by 5. So our D is going to be equal to negative 5. Now, we know that our N is going to be 22 because that's the number of terms we're looking for. And now we can substitute all of our values into the second equation once again. So A sub 22 is equal to 22 over 2 times 2 times 82 minus 5 times 22 minus 1. A sub 22, let's do a little math. 11 times 82 times 2 is going to be 164. 21 times 5 is going to be 105. We're left with S sub 22 is equal to 11 times 59, which when you use your calculator, figure that out. S sub 22 is going to be equal to 649 as our final answer. Now let's move on to the next one. Find the sum of 6 plus 9 plus 12 plus so on until plus 39. So this is the exact problem that we did before, except we have one teeny step that we have to do before. We need to figure out what term 39 is in this sequence. So what we're going to do to figure that out is we know that our A1 is equal to 6. We can see that this is consistently going up by 3, so our D is going to be equal to 3. And now we're going to substitute these values in to our A sub n equation that we know is A sub n is equal to A1 plus D times n minus 1. And we know our 39 is A sub n. So when we substitute these values in, we get 39 is equal to 6 plus 3 times n minus 1. We can subtract 6 from both sides to get 33 is equal to 3 times n minus 1. Divide both sides by 3 to get 11 is equal to n minus 1. Add 1 to both sides to get n is equal to 12. Now that we know what number term 39 is, we can use that to find the sum of all of these numbers. I'm going to use the first equation on the top of our sheet for the rest of this problem, since we know what a sub n is equal to. If you use the second equation, you would still get the problem correct. However, since we already have a sub n, that's the equation I'm going to use. So, s sub 12 is going to be equal to 12 over 2. We know a sub 1 is 6, and a sub n is 39. So a sub 12 is equal to 6 times 39 plus 6 is 45. S sub 12 is going to be 6 times 45 is going to be equal to 270. Now let's move on to the next problem. Find the sum of 50 plus 46 plus 42 plus so on until negative 26. So just as before, we have to figure out what term negative 26 is. We can see that our A1 is 50, so A1 is equal to 50. We can see that this is consistently going down by 4, so D is equal to negative 4. And our A sub n is going to be equal to negative 26. So let's substitute in all of these values into the equation we know. A sub n is equal to A1 plus D times n minus 1. So negative 26 is equal to 50 minus 4 times n minus 1. Subtract 50 from both sides. Negative 76 is equal to negative 4 times n minus 1. Divide both sides by negative 4 to get 19 is equal to n minus 1. Add 1 to both sides, and we get n is equal to 20. So now we know we're working with the 20th term. Now we can find the sum of all of these numbers. So s sub 20 is equal to, our n is 20, so 20 over 2 times a1 is 50 minus 26. S sub 20 is equal to 10 times 24, and S sub 20 is equal to 240. Now let's move on to the next problem. Heather is building a can display at the end of one of the aisles in a grocery store. She puts one can on the top row and adds 2 cans for each row. How many cans will Heather need to build the pyramid if she has 30 rows? So in this problem, let's read it again. Heather is building a can display at the end of one of the aisles in the grocery store. She puts 1 can on the top row, so that's telling us that A1 is equal to 1. She adds 2 cans for each row, so that tells us D is equal to 2. How many cans will Heather need to build the pyramid if she has 30 rows? So that's telling us that N is equal to 30. So it's asking us what S sub 30 is going to be. So we can substitute our values in to find that. So S sub 30 is going to be equal to 30 divided by 2 times 2 times 1 plus 2 times 30 minus 1. S sub 30 is equal to 15 times 2 plus 29 times 2 is going to be 58. S sub 30 is equal to 15 plus 60, times 60. S sub 30 is going to be equal to 900. So our final answer is going to be 900 cans. And now let's move on to the last one. So a stadium has 246 seats total. The first row has 4 seats, and each successive row adds 3 seats. How many rows are in the stadium? So it's telling us that our S sub n is equal to 246. The first row has 4 seats, so that tells us A1 is equal to 4. And each successive row adds 3 seats, so D is equal to 3. how many rows are in the stadium. So we are looking for n. So we know our formula, S sub n is equal to n over 2 times 2a1 plus d times n minus 1. Let's substitute all of our values in to figure out what our n is going to be. So 246 is equal to n over 2 times 2 times 4 plus 3 times n minus 1. We could simplify this a little bit. 246 is equal to n over 2 times 8 plus 3n minus 3. 246 is equal to n over 2 times 3n plus 5. Now, I want to get rid of this fraction right here, so I'm going to multiply both sides by 2 to get 492 is equal to n times 3n plus 5. I'm going to distribute my n and get 492 is equal to 3n squared plus 5n. I'm going to subtract 492 from both sides to get 3n squared plus 5n minus 492 is equal to 0. Now we have to factor. So the easiest way to factor this is to either use quadratic formula or guess and check on your calculator. I used the method of guess and check on my calculator and got 3n plus 41 times n minus 12 is equal to 0. When you solve for this, you get n is equal to negative 41 over 3 and n is equal to 12. We discussed before that n cannot be equal to a fraction or a negative number, so we can see that we have an extraneous solution. So our final answer is going to be 12 rows.